Hi again. For a long time people have asked about our filtration. And our filtration, pretty much most of them are lowly sumps, nothing special, they're just big. So I'm gonna finally show them a little bit and talk about them. So we have 4 sumps. These 2 tanks, 240 gallon tanks, are run by 1 sump. I have a bottom drain, no overflow, just 1 bottom drain. And this little strainer I just made it out of a Tupperware to hold the food from being sucked into the drain. So 1 bottom drain comes out right here. There's the first valve and the second valve, and the water is dumped in here. And there is a partial siphon, partial vacuum inside, which is regulated by this hole. The bigger the hole, the smaller the vacuum, the slower the flow of the siphon. Same here for the other tank. So they come down into the mechanical filtering part, and then it goes over into the sump, which is just full of cuts and pieces of some plasticware, also old plastic plants, shavings, and a whole bunch of hot scrubbies. There's also some pieces from matting which is used for air conditioners, etc. So the water runs down there, and then it travels about 20 feet to the other end where the pump is sitting. So the pump is over here, all the media is behind there, as you can see. The water is running from there and into the pump. The pump then pushes the water to the 2 tanks over there, okay? So it's the same system here. This is the pump. This is the bottom drain from one of the tanks, goes down. This is the continuous water change. This is fresh water being added to the tank 24/7 to the sump. And this is a system of a sump of 2 tanks. So these 2 tanks on 1 sump, these 2 tanks are about 500 gallons altogether, and the sump is probably another 500 gallons. These 2 tanks, again, the same size, about 400-500 gallons. And then they are on a separate sump, which is the same, again, full length of the tanks, running underneath. The water runs down to one end. Again, siphons, partial siphons. With the size of the hole, I can regulate whether I want level higher or lower. And the water is running down under the tanks, as I already shown. To the pump. This has the strainer, of course, on the bottom drain. All of these tanks only have 1 bottom drain, which is a problem. I need to plumb an overflow, because sometimes when things go wrong, it can overfill and the water runs on the floor. All right, these 6 tanks are on 1 sump. So these 6 tanks have a water volume of about 1,000 or so gallons, and the sump below is also 1,000 gallons. The sump is 50 feet long, maybe 60 feet long, by 2 feet wide and by 2 feet deep. So all the 6 tanks drain into here all together. I have 6 pipes. Each pipe is hooked up to a drain, just like that. Then it runs all the way to that wall over there, makes a U-turn, the water does. Right over there, and comes back under these tanks into here. So here we have 3 pumps, 1 per each couple of tanks. Here we have the media, whatever, just some scraps, mats, pot scrubbies, old plants, plastic stuff. And this is again our water change, continuous water change. The water is running in and out, into the sump 24/7, and then overflows and runs out. Okay, the 2 big tanks have the volume, combined volume of 9,000 gallons, and they're filtered by nominally 15,000 gallon sump, which also doubles it as a water reserve, but it's not filled to the top, so it's probably about 14,000 gallons of water. So the 2 big tanks do have 1 bottom drain and 1 overflow. So there is 4 pipes, 1 bottom drain and 1 overflow per each tank. And it's being dumped into this mechanical filtering chamber. And then this is the whole sump. The media in the sump is nothing but a shade cloth, all it is. It's just a shade cloth. 50% shade cloth. I'm guessing about 1,500 feet long by 15 feet wide. I think I got about 6 pieces in here. Anyhow, this is the overflow, and the bottom drain come out here diagonally from here. You see the you see the cables for the 8 pumps that supply the water back into the 4,500 gallon tanks. Each pump is about 5,000 gallons an hour. At the head that I have it at, the head is probably about, I don't know, 6 feet. So again, you see the drain. Then there are the 8 pumps. The 8 pumps push the water up through these 8 3-inch pipes back into the two 4,500 gallon tanks. Here are the bottom drains and the 2 overflows and 2 bottom drains. The bottom drains are 4 inches. I mean, they're all 4 of them are 4 inches, 4-inch pipes. You can see the strainer in the back. That's the bottom drain for this tank. And there is a different design of strainer here in the corner over there. That's the drain for the other tank. And these are the overflows. Just a 4-inch pipe. And I used a uniseal instead of a bulkhead. Much cheaper, and it works just fine. Here on this tank and on the other tank. So all 4 pipes are running down there, as you have seen, into the 15,000 gallon sump. So that's all it is, just a sump, nothing fancy. Sumps needs to be cleaned. So this is cheap but expensive in terms of labor. Kind of a setup. Alright, and the koi pond is filtered by a wet-dry filter, which is about 6 feet tall by 4 feet wide by 8 feet long. You can see the media, the pot scrubbers on the bottom. The water just runs down on them, rains down on them, and then everything just being dumped back into the koi pond. Right now there is only 5 pumps working. Each pump is 6,000 gallons an hour, so this is about 30,000 gallons an hour flow for a pond which is filled to about 20,000 gallons. So we're getting 1.5 turnovers an hour. And I have the capacity, I have 10 pumps in the back where you can see the pipes. There are 10 pumps, so I can double the capacity to get it to 60,000 gallons an hour and up to 3 turnovers an hour. So this plywood box houses that trickle filter. The pumps, as you have seen over there, those are the 10 pipes for the pumps. They pump the water up into an aqueduct. This is an aqueduct. The water runs in the aqueduct, gets aerated. Gets aerated, and then it is dumped into the trickle filter. Comes out right here. Instead of the ground water flow control fabric, which I had to vacuum too much, but now I'm using the medium density mat for just the physical, for the mechanical portion of the filter. And this I have to clean maybe once a month or once in a couple of months. All this water getting dumped in a rain fashion, more or less equally, over 10,000 pot scrubbies that are below that you have already seen. So this is the trickle filter for the koi pond. Again, it's pretty simple. Just the scale is big. I forgot to show you the pumps up close. This is the aqueduct on the top. It's about 50 feet long by 4 feet wide by 1 foot deep. So those are the pumps, the 10 pumps, 6,000 gallon an hour each at my head, which is about 10 feet. Nominally they are 6,600 gallon per hour. So they push it into the aqueduct, and then the aqueduct guides the water into the filter, and there it is being dumped back into the koi pond. These are the continuous flow. This is from the two 4,500 gallon tanks overflow, the continuous overflow, I should say. So this is the amount we change 24/7, 365. We'll get about 100% water change every 6 days. The reason for such a large diameter is because once in a while when we have to empty 4,500 gallons tanks quickly, we need a lot of water being dumped into the koi pond. So we need a 6-inch pipe for that. And these three are the continuous water change from the smaller systems. These two, this is from the 6-tank system, and these two are from the 2-tank system each. So all of this combined travels underground, and here it is dumped into the hospital tank, which has no filter. So this is about 5,000 to 6,000 gallons a day. This is the flow of the water that we change. This is the water change. Then it comes out here. I have removed temporarily the sand filter. This is demanded by the Florida Wildlife Commission. There must be a sand filter here. And then this whole thing goes out into the lake. So this is the continuous water change that we have going. Our well water is hard and brackish, about 1500 ppm, out of which 600 ppm is the hardness, calcium and magnesium. So I'm gonna show you the pump house and the RO system. We have to have 6 RO membranes running again 24/7. And each produces 2,400 gallons a day of RO water when it's new and fresh. But they get plugged up pretty quickly. So right now they're about 2 years old. They only can make about 900 to 1,200 gallons a day of RO water. So this is a pre-filter, and then there is 1, 2, 3, 4, 5, 6 RO membranes. Each membrane is about 3.5 feet tall. You can see how wide it is. So we have a well pump supplying the pressure, and then there are 2 booster pumps that boost the pressure up to 100 psi. This is a low pressure RO system that requires no softening of the water before it hits the RO. But then it also ages the membranes that get plugged up with the calcium carbonate deposits. These are again just a pre-filter. This is a mechanical pre-filter. And then the water gets dumped into this storage tank. Pure RO water is bad for the fish and for you. So what you can see here is that I'm adding this through this garden hose. I'm adding some of the well water back and mixing it with the RO water at about ratio of 1:5, 1:6, and then we drink the same water as well. The fish and us get the same water. So that's pretty much it. Thank you guys again for your attention, for your kind comments and support. It does mean a lot to us. This is, as you can see, it's a pretty much one-man show. It's a do-it-yourself enterprise that has been a very long time in coming. It's been 7 years since I started building the pavilion. And even before that, we started working on the financial stuff, etc., and on paperwork. So hopefully we'll open one day soon for business as a public aquarium, and people can come and see our animals and learn about them. Thank you again. Bye.